Okay, hello. This time we're going to discuss about graphing quadratic function in standard form. So we're going to identify the axis of symmetry, the vertex, and the intercept of a given parabola. Okay, so this is the standard form of a quadratic function. Y equals ax squared plus bx plus c. Okay, where ax squared is the quadratic term, bx is the linear term, and c as the constant term. So what is the linear term of the function y equals 4x squared minus 3? Okay, 0x because we do not have linear term. How about here? What is the linear term of y equals x squared minus 5x? Okay, so it is negative 5x. What is the constant term of the function y equals x squared minus 5x? Okay, so we do not have constant term, so it's 0. Then, can the quadratic term be 0? Yes or no? No, because if your quadratic term is 0, then it is no longer called quadratic function. Okay? So let us review some of the concept. The graph of a quadratic function is a parabola. Okay, a parabola can open up or down. The parabola opens up and the vertex is the minimum point. And if the parabola opens down, the vertex is what we call the maximum point. Okay? If the parabola opens to the left or to the right, then it is not a function. Okay? So we have here, again, the standard form of a quadratic function is y equals ax squared plus bx plus c. So before we discussed already graphing a parent function, y equals x squared. Okay? If a is positive or greater than 0, then the parabola opens up. But if your a is negative, then the parabola opens down. Okay? Again, as what I have told you, a should not be equal to 0. Because if a is equal to 0, then it is no longer a quadratic function. Okay. So we have here, if we drew a line down the middle of the parabola, we could fold the parabola in half. So we have here, the blue lines represent the axis of symmetry. Okay, so that is called the axis of symmetry. If we graph one side of the parabola, we could reflect it over the axis of symmetry to graph the other side. So we have that, the half of the parabola. So meaning to say, the line, the axis of symmetry is here. Then you just reflect it. Then that is already the quadratic function, or that is already the parabola. Okay? You always remember that the axis of symmetry always passes through the vertex. If you can remember, we have your axis of symmetry is actually your x coordinates on a vertex. Okay? So next, will be the next one. Okay? This time, let us try to find the axis of symmetry in its standard form. Okay, so what is the axis of symmetry? The axis of symmetry of a quadratic function in its standard form can be found through the formula x equals negative b over 2a. That is negative, okay? It's just a typographical error, okay? So that is the formula. Whenever you are given with a quadratic function in its standard form, you're just going to use this formula in order to find for the axis of symmetry. Okay? This is best read as the opposite of b divided by the quantity of 2 times a. That's opposite, okay? So we have here, find the axis of symmetry for y equals 3x squared minus 18x plus 7. So how to find for the axis of symmetry? We have here the formula. Of course, you're going to find for the value of a and the value of b. The value of a is the coefficient of x squared, which is equal to 3. And the value of b is the coefficient of x, which is negative 18. And so, we're going to apply the formula x equals negative b over 2a. Okay? So, we have here, since your b is negative, so you have negative times negative, it will become positive, divided by, that must be 2 times 3. 2, and here a is 3, so that is equal to 18 divided by 6, and that is equal to 3. So the axis of symmetry is equal to 3. Okay? Now, let us try to sum it up. The axis of symmetry always goes through the vertex. Thus, the axis of symmetry gives us the x-coordinate of the vertex. Okay, let us just have a shorter view. The coordinates of your vertex is x, y. Your x here is what we call the x, or the axis of symmetry. I'm sorry. This is your axis of symmetry. Okay? And your y is what we call the minimum point, minimum value I should say, or the maximum value. Okay? So, through the vertex, you can already answer three concepts regarding quadratic function. Okay, so we have here, find the vertex of y equals negative 2x squared plus 8x minus 3. So how to find for the vertex without graphing? So in order to find for the vertex of this quadratic function without graphing, you need to find for the axis of symmetry first. So what is the formula? Again, this is a typo. X equals negative b over 2a. So you need to identify your a and your b. So your a there is negative 2 and your b is equal to 8. And then after that, you're now going to substitute the value of a and b. So your your b is 8, so negative 8 divided by 2, and your a is negative 2. So it is equal to negative 8 divided by 2 times negative 2, that is negative 4. So negative 8 divided by negative 4, that is equal to 2. So that is now your x-coordinate or your axis of symmetry. So you have there, your vertex has a coordinate of, your x there before is 2. This time, we're going to find for the value of y. So how to find for the value of y? We are just going to substitute the value of x on the original equation. So you have there y equals negative 2. You're going to plug in here your x and then your x. Okay? So you have there 2 and then 2. So y equals 2 times 2, that is 4, times negative 2, that is negative 8. So 2 times 8, that is now 16. So negative 8 plus 16 minus 3. So you're just going to simplify it, I should say. So negative 8 plus 16, that is 8, minus 3, so that is equal to 5. So your y is 5. Therefore, the vertex is 2, 5. Any question? Okay? Now, let us try to graph the given quadratic function in standard form. How are we going to graph if the given function is already written in its standard form? Of course, it would be easier for you to find for the axis of symmetry. Okay, the formula again is x equals negative b over 2a. And then find the vertex. Okay, and then the last one is find two other points and reflect them across the axis of symmetry. Then connect the 5 points with a smooth curve. Okay? Using an x tables close to the axis of symmetry. That will be easier. Okay, so let us try this one. Let us try to graph y equals 2x squared minus 2x minus 4x minus 1. So how are you going to graph it? So first, find for the axis of symmetry. What's the formula? We have x equals negative b over 2a. So your a here is 2 and your b is negative 4. So you're just going to plug in. B is negative 4, so you have here negative 4. That's why we come up with positive 4, because negative times negative is positive. Divided by 2 times 2, that is 4. So 4 divided by 4, that is 1. So that is now your x. How to find for your y. Okay? So that is your 1 is also your axis of symmetry. That is 1. Then after that, we're going to find for your y. So how to find for your y? Use the given equation. Okay? So we're going to use again the given equation. So you're just going to substitute the value of x. So 2 multiplied by 1 raised to 2 minus 4 times 1 minus 1 equals negative 3. How come that is negative 3? So 1 times 1, that is 1, times 2, that is 2. Negative 4 times 1, that is negative 4 minus 1. So 2 minus 4, that is negative 2, minus 2, that is negative 3. Therefore, your y is negative 3. Okay, so the vertex will be 1, negative 3. It is there. Okay, so we're done with the vertex and the axis of symmetry. Again, your vertex is 1, negative 3. Okay, so that's the vertex. Now this time, after finding for the vertex, we're now going to find two other points and reflect them across the axis of symmetry. Okay? So let us assume 2 points. Let us assume x is equal to 2 and 3. So you're just going to use the given equation y equals 2x squared minus 4x minus 1. So you're just going to plug in 2, your x is 2, minus 4, your x is 2, minus 1. So 2 times 2, that is 4, times 2, that is 8, minus 4 times 2, that is 8 minus 1. So 8 minus 8, that is 0, minus 1, that is negative 1. So if x is 2, y is negative 1. Now, how about if your x is 3? So do the same thing. Y equals 2. Substitute 3 on your x, minus 4 times 3 minus 1. So you have there 3 times 3, that is 9, times 2, that is 18, minus 4 times 3, that is 12, minus 1. So 18 minus 12, that is 6, minus 1, that is equal to 5. So we have here 5. Okay? So what's the value? Okay, we are right. And then that is 5. Okay? So let us try to clear out the screen. Okay, so you have there, if x is 2, y is negative 1. And then, if x is 3, y is 5. So, the graph there is there. Okay? And then after that, you're just going to reflect it. So, from here, you're just going to count from the axis of symmetry their distance. So, it is reflected there. While here, 1, 2. So, the reflection is 1, 2. Okay? And then after that, connect the points. So, you have there the graph of the given quadratic function. Okay? How about here? What is the y-intercept of a quadratic function? Try to observe. What does it mean when we say y-intercept? It is the point of intersection of the graph along the y-axis. And where is that intersection? It is here. This one. Therefore, this point represents the y-intercept of a quadratic function. What is the coordinates of this y-intercept? What is your x here? It is 0. And what is your y? It is negative 1. So your y-intercept here is negative 1. It is the point where the graph crosses the y-axis. Okay? So there is another way to find for the y-intercept of a given quadratic function. And what is that way? You're just going to substitute x equals 0. Okay? Because your x here is 0. That's why you're just going to substitute your x by 0. So, do the computation. Y equals 2x squared minus 4x minus 1. So, to substitute your x equals 0 raised to 2 minus 4 times 0 minus 1. So, 0 times 0, that is 0, times 2, that is 0. 4 times 0, that is 0, minus 1, so that is negative 1. Okay, did we come up with the same answer? Yes, that is your y-intercept. Now, try to observe the last term. That is also negative 1, right? So, meaning to say, what does it mean? It means that your y-intercept is always the constant. So whatever will be your constant here, if it is in a standard form, then that is your y-intercept. Okay? So we have here, going back, this is the graph of the parent function f of x is equal to x squared. Okay? So that is the parent function. Now, let us try to identify the movement or the translation of the parent function. What will happen to the parent function if d is positive? Okay? So we have here x squared plus 3. Why is it was erased? Okay, so this is our parent function. This is the graph of f of x is equal to x squared. Now, this is now the graph of f of x is equal to x squared plus 3. What is the sign of your 3? That is positive. Okay? So try to observe what happened to the graph if your d is positive. Okay? It moves up. Okay? What happened if your d is negative? Of course, it will move down. F of x is equal to x squared minus 2. So from the point of origin, you're just going to move 1, 2 down because the sign of your d is negative. Okay, so that is the vertical translation of a quadratic function. Okay, how about the horizontal translation? We have here, this is the parent function. F of x is equal to x squared. What will be the movement if your c is negative? Okay, if your c is negative, the graph will move c to the right. So you have there y equals, why is it that? The square of x minus 2. That is negative, but it will move to the right. What if your c is positive? Of course, it will move to the left. Y equals the square of x plus 2. That must be positive. Okay? So that is the horizontal movement or horizontal translation of a parent function. If your c is negative, it will move to the right. If your c is positive, it will move to the left. Any question? Okay, so that is what we call the horizontal and the vertical movement or translation of a quadratic function.